Okay, so we're gonna go over practice exam number 5. Alright, starting with chapter 7. So we have some word problems. So the first question says a 40-foot ladder on a fire truck. Okay, so it's always good to visualize this. Right, so this is MAC1147. Practice exam number 5. And so we're gonna go ahead and visualize this problem. Okay, so a 40-foot ladder on a fire truck. So I'm gonna draw a fire truck or something. Okay, so a 40-foot ladder is leaning against a burning building. Okay, so put the ladder right here. Leaning against a burning building, right? Something like that. Okay, you can label it. Such that the top of the ladder makes an angle of 20 degrees with the building. Meaning that right here, this angle makes 20-degree angle. Okay, of course it's not drawn perfectly, but we get the picture. If the bottom of the ladder is anchored to the top of the fire truck 6 feet off the ground, right, so this distance of 6 feet off the ground is where the ladder is starting. And then it says, how far above ground does the ladder reach? Okay, so in other words, all the way this distance of the building where the ladder touches against the building. So we're gonna solve for this x. Okay, so as you can see, there's a right triangle here that is formed, right? Okay, and so we're gonna use the fact that in a triangle, we have 180 degrees. We have a 90-degree angle, right, that is formed with the vertical and the horizontal with this scenario. So you subtract the 90, subtract the 20, right? And that's gonna give us 70, right? So this angle is 70 degrees. And why did I do that? Well, technically you could use the 20 degrees, but the reason I did that is because I wanna try to solve for x, right? I wanna see how tall this building is to the point where the ladder touches it. And so what we're gonna do is we're gonna think about our trig functions. Okay, so here, if I use the 70 degrees and I have opposite, adjacent, hypotenuse, I know that if I get the sine of 70 degrees, because sine is opposite over hypotenuse, that would be opposite over 40, right? And then I can solve for opposite, right? So I'll call it opposite. All right, so let's do the math, the algebra. So opposite is 40 times sine of 70 degrees, which when you plug it in is 37.59. You can check. I like to round to the hundreds place, even though the book likes to the tenths place. So we're gonna stick to the hundreds place. Okay, so that means that this distance is, of course, it's not drawn to scale. This opposite is 37.59 feet. Okay, but don't forget the 6 feet that we need to add because the ladder started, of course, we're measuring from the ground to the top of the building where the ladder touches. So we need to make sure that we add the 6 feet of the truck where the ladder is on top of, right, or connected to. So make sure that you get the 37.59 that you got, and then you add the 6 feet. So it's about 43.59 feet. Okay? Perfect. So that's number 1, word problem. Like I said, you could just stick with the 20 degrees that was created when the ladder touched the building, but in that case, then you would have this side be opposite, this one be adjacent, this one be hypotenuse. Use a different trig function, such as cosine, right? Cosine of 20 degrees is adjacent over hypotenuse, but once you find adjacent, you still need to do the Pythagorean theorem to find once you find this side, so I'll show you what I'm talking about. So let's say you wanted to stick with the 20 degrees that they gave you, then you would label this side opposite, this one adjacent, that one hypotenuse. I know I can still do sine of 20 degrees, opposite over hypotenuse. But once I get the opposite, of course that's not what we want. What we want is the adjacent, right? We want this length. So you would still have to do the Pythagorean theorem to square the legs, all that stuff, in order to solve for it. So it's better to find this angle and then just go for what we want. Okay. Number 2, another word problem. So here we have a straight hiking trail. Okay, so I'll just do something like this, like a trail that we're walking on, right? Is 2,500 feet long. With a gain in altitude of 310 feet. To the nearest degree, what is the average angle of ascent? Okay, with a gain in altitude, this is how I did it when I worked on it earlier. Okay, 310 feet, and then to the nearest degree, what is the average angle of ascent? Adjacent. Okay, so if this person is walking this trail, right, that's 2,500 feet long, and then eventually it is a gaining altitude of 310 feet, then this person essentially is going to be walking uphill, right? So then we're trying to figure out what is this angle, right? So based on this angle that he is, the incline that he's going at, we can label this side opposite, this one adjacent, this one hypotenuse. And so if I have opposite and adjacent, which trig function would you want to use? I would want to use tangent, right? Remember that tangent of the angle is opposite over adjacent, which is 310 over 2,500. Okay, so plug that in and you get 0.124. And then, since I'm trying to find theta, or the angle, this is in radians, I'm going to go ahead and find the arctangent of both sides. So that's going to cancel, leave me with just the angle, and I'll also get the arctangent of the other side. Okay, remember arctangent returns our first or fourth quadrant. And so here when we get the arctangent of 0.124, we get 7.07 degrees. Okay, so that's the incline. It's a very small incline. Okay, over time, as he's walking this long length, he is starting to incline, and with an ascension, overall gain of ascension of 310 feet. Okay, so there you go. And then of course this makes logical sense. 7 degrees incline, makes sense. Okay, so that's the word problem, 7.1. Now we get to use the law of sines, which is super simple, right? It's the ratio of the size of the triangle with the sine of the angle corresponding to it. And based on that, we can find the missing portions in a triangle. Remember that sometimes we cannot form a triangle, sometimes we can form one right triangle, one oblique triangle, or two triangles. Okay, so let's get to it. So this is 7.2, law of sines. So here it says we have a triangle ABC, and it gives you some information. And remember that I told you guys in class that recommendation, you don't always have to do it, but that it's helpful to make the base of the triangle the side that's not given. So here for number 1, skill practiced, actually, yeah, number 1. And did I skip that one? No, I did that one. Okay, so we're gonna label it. So they gave us B, angle C, and they give us side B. And it's our job to find the rest of the triangle. So let's go ahead and label the triangle. We don't assume it's a right triangle, at least not in the beginning. So here I'm gonna go ahead and I'll label the bottom either A or C. So I'm just gonna do A, B, C. Okay, so B is 15 centimeters, C is 48 degrees, and B is 70. Now we know that the angles in the three angles in the triangle have to add up to 180. So we can easily get this angle since they gave us two of them. So we could do 180 minus 70, which is 110. And then subtract 48, and we get angle A of 62 degrees. Okay, so that was easy. Okay, now we still need to find side A and side C, and that's where we'll use the law of sines. Okay, let's see, I'll do it up here. So we want to find, let's go ahead and just start with A. So since they gave us side B and we also have the angle for B, we're going to use that as part of my law of sines. So I'm going to do side B over sine of 70 equals, and I'm going to solve for A, so I'm going to make it A over sine of 62 degrees, and you guys know how to do the algebra, so multiply, right, multiply the sine 62 degrees to cancel, do the same thing on the right hand side, then you get your A. Right, so I'll do the first one. Try to solve for A. Whatever you do to one side, do to the other. So we're gonna have to multiply this left hand side by sine of 62 degrees. Right, so when you plug into the calculator, you should get 14.09 for A. Again, pause the video, check the work, and make sure that you're getting that as well. Okay, and then similarly for C, I'm going to use the same left-hand side, the one that uses B that's given, and I'm going to solve for C, so I'm going to make it side C over sine of the angle C, which is 48 degrees. Right, then you do the algebra, and you should get C equals 11.86. Okay, awesome. This is going back to law of sines. Okay, moving on to skill practice 3. This is still 7.2. Okay, so what do we have? They give us angle B, B, and A. Oh, I was looking at the wrong one. They gave us angle A, side A, and side B. Okay, so again, my recommendation is to, when you label it, you can label however you want for the triangle. But I like to make it so that the side that we're missing C, is the base. So we're going to make this side C, angle C, and then we could do A, B, C. Okay, good. And they label B as 28 and A as 32. Units, right? Whatever units. Okay, so it says, round the measures of the unknown angle inside to one decimal place. Like I said, we're going to do 2 decimal places, which is the hundredths place. So we're going to go ahead and see what can we do. So again, back to law of sines. because they give me angle A and side A, I'll use that ratio. So I'm going to do A over sine of A equals, and then since they gave me B, I might as well go ahead and start solving for angle B. Okay, so just plug in what you need to plug in. Right, this is a general formula, and then I'll plug in. Okay, we're solving for B. So back to algebra. Let's get our B to be on top, but canceling the denominator, right? So then we get sine of B times 32 over sine of 49 degrees equals 28. Okay, but I want to get this sine B alone, so I'm going to go ahead and multiply by the reciprocal so that I can cancel. So I'm going to multiply by sine of 49 degrees and cancel these guys, and then divide by 32 so I can cancel the numerator and denominator, right? So now I just have sine of B, but again, whatever you do to one side, you're going to do to the other. Again, you can pause it, check it algebra, make sure it makes sense. Okay, so then when we plug in 28 times sine 49 degrees divided by 32, let's see. I may have skipped this one. Yeah, I didn't work this one out, which is fine. You just plug in, so let me plug that in really quickly. Okay, so we're gonna do sine of 49 degrees. Ta-da! Okay, so sine of 49 degrees is 0.75. And then I'll multiply that by 28, divide by 32. 0.75. Forgot to bring my calculator. Okay, so that's 21, and then 21 divided by 32. Gives 0.66. Okay, so sine of B is equal to 0.66. Again, algebra. Okay, and then now we want to get B, so we're going to get the arc sine of both sides, right? So this is going to be the arc sine of 0.66 gives me B. Okay, so let's see what we get. Arc sine of 0.66. Okay, I'm gonna put it in degrees because this is an angle, and so I think it's more beneficial to have degrees, right? So let me, it's in radians, let me put it in degrees. Alright, so I'm getting 41.30 when you round. Okay, so angle B is 41.30 degrees. Okay, beautiful. And then last but not least, based on that, we can go ahead and continue. Now you may ask yourself, because we have seen before two triangles, right? based on what we get. But remember that we also have other requirements. So in a moment, I'll go back and I'll talk about the lengths of the sides. Okay, so but for now, if we have 180 degrees as the total of the 3 degrees in any triangle, and we take away the 49 that was given minus the 41.30, we will get this missing angle. Right, so I'll just plug it in since I haven't done it yet. 80 minus 49 minus 41.30. 89.7. Okay, awesome. Okay, now going back to the two triangles. So if you call two triangles, remember that this could happen based on angle B. You can have an obtuse angle or you can have an acute angle. So let me make this a little better. Obtuse angle over acute angle, right? Something along those lines. Acute angle, that's how you draw it. Or obtuse angle. Okay, so remember for this one, it's like this. The height of a right triangle, because remember you can always create a 90-degree triangle within the triangle in order to find height. We don't really do it often, but it's supposed to be A is greater than height, side A, and B is greater than A for the two triangles, right? For the oblique triangle, as A is greater than B. And as you can see here, 32 is greater than 28. Okay, so here we only have one triangle, okay? I know that in class I said before that you can switch A and B. It looks like the book, it seemed like the book had done that, but I say whatever they give to you, stick with it, and we're gonna use our A's and our B's and we're gonna stick to them. We're not gonna swap them because then it gets a little bit confusing. Okay, so according to this, we have one oblique triangle, right? And this we did in class, we drew the figure with the 4 triangles and the possibilities. Okay, so based on that, we have one triangle, and so we have, we still need to find side C. Okay, so I'm using law of sines, I'm using B and C, and I'm plugging in. And so I'm trying to solve for C. So let's do some algebra. Get our C to be alone. Okay, so now we have to plug that in and get our C. Again, you could use A on the left-hand side, or you can use B on the left-hand side, since we have side A and angle A and side B, angle B. Okay, let's plug this in. So sine of 89.70. Okay, we're leaving it as radians. We got 0.99. And then sine of 41.30. negative 0.44. Okay, wait a second. Okay, so 41 degrees is in the first quadrant. Sine in the first quadrant is positive, so something's happening here. Plug in somewhere else. I have the final answer, but just for the sake of plugging in and doing it together. So sine of 41.30 for the denominator. Okay, 0.66. That's why it's always good to be able to pause and check yourself and be like, hey, this is in this quadrant. Sine should be positive in this quadrant, right? Okay. Okay, so now we're doing 0.99 times 28 divided by 0.66. Divided by 0.66. 42. Okay, the book got 42.4. Close enough. Okay, so we got all of our parts. We got C, we got angle B and angle C, all the missing parts of the triangle. Okay, this is one oblique triangle. Feel free to go back, watch again, pause, practice, redo. Also, don't forget to do your homework. Very useful to not just bank on the practice exams, but to also put in the work yourself in the homework practice. Okay, so let's look at the next problem that I created. Okay, there it is. Okay, moving on to the next one. Okay, next one is number 5. So in one more, we have B is 31 degrees, little b is 3, and side A is 6.2. Okay, so based on this, I'm missing side C. I'm going to make C the base. Again, this is useful when there are 2 triangles. When we do create 2 triangles, you never know when that happens. So this is 31 degrees. This is side B, which is 3. This is side A, which is 6.2. We have to find all the missing parts. Okay. Okay. So because they gave me B, and I'm still in 7.2, which is law of sines, I'm going to go ahead and do B over sine of angle B. And then I'm going to go ahead and solve for what I need. So we're going to use A and try to solve for angle A. Okay, so again, we're going to do the algebra. Required, cancel the denominator. Remember, I'm trying to get my A alone. Okay, so this gives me 6.2 equals sine of A times this. Okay, I'll pause. Remember, you're trying to solve for A, find where it is. It's on the right hand side. It's in the denominator. I'm going to have to cancel it out. Whatever you do to one side, do to the other. Again, I need my A to be alone, isolated. So I'm going to go ahead and multiply by sine of 31 degrees to cancel these guys, and divide by 3 to cancel these guys. Now my sine A is alone. Of course, what I do to one side, I'll do to the other. So then we get sine of A equals, and plug that into the calculator, and let's see, and you get 1.06. Okay, you should already notice that. Remember that for sine, regular sine function, the minimum is -1 for the range, and 1 is the max. And this is past 1. This is 1.06, which means that it is, that's not good, right? So this is not possible. So if we get the arc sine of both sides, in order to try to solve for A, you're going to see that it is not possible. So therefore, we are not able to create this triangle. Again, you could go back to the rules and whatnot, but at the end of the day, I think it's also useful to just go for it and say, hey, I got stuck. Hey, this is impossible. Or hey, I could create two triangles. I see that this angle is small enough that I can create a different one. Again, going back to, at that point, you do have to check A and B for the two triangles. Okay, but for the others, you can just go for it and see what happens. Okay, so in this case, there's no triangle that's able to be made or created. Something. Okay. All right, and then the last one for 6.2, we are given angle A, B, and we need to find the rest. So we need to find angle B, angle C, and side C. Okay, again, we're missing side C, so I'm going to make this C. So B is 25, A is 22, angle A is 40, and I need to find the rest. Okay, so I'm going to go ahead and try to use my law of sines. Law of sines. Okay, so they gave me A, so I'm going to use A. So 22 over sine of 40. And then they give me part of B, so I'm going to go ahead and try to solve for angle B. Okay, again, do the algebra, so let's get our B alone. You can take your time and check it. Okay, but this is going to give us, let's find it. Okay, this is going to give us 25 times sine of 40 divided by 22, which is 0.73. Okay, so that's good. This is within the range of sine. So let's get the arc sine now to get my B alone, which is the angle that I need. Right, so remember for arc sine, you have the same as arctangent in the sense that you're looking from pi over 2 to negative pi over 2. So it's going to give us an angle in the first quadrant or the fourth quadrant, right? Okay, so when we plug this in, arc sine of 0.73 gives us 46.89. Okay. All right, that's a clearly in the first quadrant. Something like that. Okay, now going back to the rules for 2, because we don't know, this could be an acute, one of the triangles can be acute, and then the other one could be, let me make sure the draw is good. Or it could be, B is obtuse, right, which is greater than 90. All right, so let's check the requirements. So it's supposed to be A is less than B, which here we have 22 is less than 25. And then A has to be greater than H. Okay, how do you find that H? We've talked about that before in class. You could create a 90-degree triangle. Okay, I'll do it really quickly over here. So we could create a 90-degree triangle within this possible triangle. Okay, we can use the fact that we have this angle here of 40 degrees. This would be the opposite. Here we have adjacent. Here we have hypotenuse. So, and they give us hypotenuse is 25, right? So going back to 7.1, if I use the sine function, sine of 40 degrees is opposite over hypotenuse, which I'm actually gonna call this, don't get confused, I'm actually gonna call this height of the triangle. So sine of 40 degrees is opposite, which I'm calling height, over the hypotenuse, which is already labeled as 25. So this is how you can find height for any possible triangle to see if it does satisfy the requirements. Right, so let's go ahead and use the calculator. I didn't do this earlier. Let's do 25 times sine of 40. Okay. Okay, so let's do 25 sine of 40. Okay, so that's 0.73 times 22. That's 16.06. Okay, so the height of the triangle is 16.06, which is indeed less than A, less than 22. Right, so this is a two triangle scenario. Okay, check it out. Okay, and so let's go ahead and see what that other angle is gonna be. Okay, so remember that we can have, now remember that, you know, scratch out arcsine for a second and go back to the fact that sine of B is a positive value. Remember that sine is positive in the first and second quadrant, right? Y is sine, right? So we're gonna find the second quadrant angle. How would we do that? Well, this line is 180. If I take away the angle that I got when I did the arcsine in the first quadrant, then that's going to give me this second quadrant angle, theta. Okay, so just let's do the math. $133.11. Okay, here, yeah. So then this. Let me erase this for now. No, that's fine. Okay. And then this B could also be 100. Again, it's not drawn to scale. This has to look different. Okay, so I have two possibilities so let's go ahead and erase this and let's keep track of our two triangles. Okay, so for triangle 1, we're getting that the angle B is 46.89. Or we can get for triangle 2, which is the obtuse triangle, we're getting 133.11 degrees for B. Okay, using that, we'll get the rest of the information that is required. Okay, so then we know that all the angles in a triangle add up to 180, so we'll do 180 minus the angle they give us, minus the potential acute angle. Okay. This will give me angle C. the other angle. So that's gonna be 93.11. And then on this one, 180 degrees minus the 40 minus the potential obtuse angle is gonna be we got 6.89. Okay. Okay, awesome. Again, the book rounds to the tens place, I did it to the hundreds. And then, of course, you still need to find the missing information. So we found angle B, angle C. We still need to get side C. Okay, I'm not gonna go ahead and do that, but I could tell you the answers and you guys could check it. But how would you do that? Use law of sines, right? So you can use the fact that they give you A, and then you can use angle C and get side C, right? So you can at least set it up. So you can set it up as, okay, they gave me A, so I'm gonna make it the side A over sine of angle A equals side C that I'm looking for, and then sine of angle C, which we already found to be 93.11, right? Once you do the algebra, you should get your answer. Use a different color, so you should get, let's see, what you get C is 34.2. I didn't continue with this one, so get close to that. Okay, and then this C would be 4.1 using law of sines. Alrighty, those are the answers. Okie dokie. So that's it for law of sines. I'm not gonna do the bonus one, alrighty, but I will put the formula for you. So they give you angle B, they give you side C, side A, and you need to find the rest. Okay, so the law of cosines allows you to find missing sides. So since they give us side A and side C, we're gonna solve for side B. Okay, and then just use the formula. So I recommend to have all the formulas because you don't know which sides I'm gonna give you, and you're gonna wanna find the missing side using the formula. So for bonus, here we go. So we're missing side B, so we're gonna use the formula. So it's B squared equals C squared plus A squared minus 2AC cosine B. Okay, and then you plug in, guess I might as well do it. They give you C, they give you A, here you go. Give you C. I want to be consistent. Okay, I think it's better to write it this way. Okay, and then they give you, thankfully they give you angle B as well. So then all you have to do is plug in, okay? Alright, so then when you plug in cosine of 61 degrees, okay, and you round to the, so actually I was looking at it, and I would round it to the hundreds place, and it'd be 0.48 for the cosine of 61 in radians. Okay, remember we want to be in radians because we're trying to find the side length. Okay, so I also noticed in the calculator, if you just leave the entire long number, you actually get a more precise answer. So it's up to you if you want to round to the hundreds place as soon as you plug in cosine of 61, which is what I usually do, and then take it from there. Or you, since you already have it in your calculator, just plug it in, get the cosine of 61, it's going to be 0.4 and a bunch of numbers. And then you multiply that by the 19, the 28, and the 2, and you're going to subtract it from these numbers. Okay, so what's 19 squared? 361. 28 squared, 784. And then minus 629.60. Okay, great. Oh, sorry, one. Let me just redo it because I guess I didn't plug it off. Okay, so if you, again, if you do cosine 61 degrees and you get the entire long number, leave it like that in your calculator, multiply by the 19, the 28, and the 2, and you're gonna get 515, you can check yourself, 0.84, okay? Then once you add these values, that's like 1,000 something minus this value, gives you 629.16 for my b. Remember that this formula is for b squared, so if we want b, we want to square root both sides, right? So when you square root this number that you get, when you do all this correctly, you get 25.1, which is exactly what we want. Okay, so that's the precise answer. Okay, so that's it for chapter 7. I'm gonna pause this video and create a new one for chapter 8. Okay, keep up the good work, keep on studying. I'm sure you do great on this.